Just waiting for some more people to come. How's everyone doing tonight?
Really good.
Good. We all masters of that 60 D Street now?
I wouldn't say so.
Good, good. We're gonna do lots of plotting today. Kind of a short lecture with more plotting. So we'll see how it goes. We'll need both charts today. We're gonna start with the training chart and then do our big 3-day plot on the San Pedro channel. So we'll need both charts, plotting tools.
And you're gonna get out, right?
I'll wait a couple more minutes to get people on. Any questions with anything? You guys finding enough information on the Google Classroom or the videos, or you want me to do a video of something else? Let me know. I wish I could, see you guys and see how your plotting's coming along, but I'm hoping everyone's getting it. Let me know if you have questions. All right, got a couple more.
I feel embarrassed to ask my question.
Go for it.
So when I'm doing all these, it's somehow I didn't get about this compass rose, and you're always using that to find our course, and but it sits on a chart at different angles, right?
So not exactly. Let me share my PowerPoint and hopefully that can help answer your question. Okay, so let's bring this up here. Okay, so the compass rose, for how we measure degrees or courses, bearings, all of those things, is by a number on a circle, right? And so the center is where all of our bearings are coming from, and then north is 0. So we have 0 as our north, and then 90 degrees to go east, and then it's 180 degrees to go south, and that's from north because north is that reference point. So 180 degrees is from north, 180 degrees, and then to west it's 270 degrees. And so we all go to clockwise from north. So this would be essentially, 359, 360 is then again 0. So north is our reference, and this is for any compass. Now, when we have that tilty compass, if this is true, excuse me, I can't write. If this is true, then that north point, excuse me, whoop, is going to that geographical north point on the globe. So that's kind of like our made up true north, and that's where we're referencing everything from. Now, where you see the north tilted one way or another is when it's pointing to magnetic north.
Right.
Right? So but the same numbering system is the same, it just has a different reference point. So everything we put on the chart when we draw a line needs to be in true.
So anything that's in 270 to 360 is going to be northwest.
Correct. Correct. It's going to be in this quadrant.
But if you're traveling, I remember one of these things you said, if you were going this way, it would be in the 100.
Yes. So
If you're going this
if
way,
we have a line, we're going from down here to up here. If we're going this way, we start from the center, and it's going to be, you know, in between 270 and 360. If we go this way along that same line, it's going to be between 090 and 180. So we always start from the center.
great. I just needed to see it, I guess. I just like, it's the same line.
So
But
this would be a line all the way across, but where you're always starting at the center and then either going this way or this way.
Got it. Okay.
One way or the other. Yeah. Cool.
Thank you.
You're welcome. No problem.
Sorry if I slowed the class down.
No, we got a short lecture and then we're plotting today. Lots of plotting. Any other questions I can help you with? Conceptualize some of these weird concepts. All right. Well, last week, we did our 60D street and practicing time, adding and subtracting time, all of that kind of stuff. And then the week before that, we did our compass corrections. So this week, we're kind of putting those two things together. And we briefly went over dead reckoning and how that is put onto the chart. And so now we're going to combine our dead reckoning with actual plotting of positions. We have a short lecture, and then we'll do a plot together on the training chart. And then we'll get started on a 3-day voyage, a big one, on the San Pedro Channel chart. So hopefully we'll get through at least day 1, maybe day 2 of that. Hopefully you guys get most of the homework done. Yeah, we're gonna get started. Any questions before I switch over? All right. Okay, so DRs, LOPs, and fixes. We're first going to remember what our DR is. Remember that stands for dead reckoning. And we need 3 things to plot a DR, or dead reckoning position. You need a starting point, so you need a known position, whether that known position was 5 minutes ago or 2 days ago. It just needs to be a known position at some point.
Rocco, shut up.
If you guys want to go on mute, that's fine, but holler in anytime you guys want to say anything. And then the 2 other things, so you need a known position, and then you also need course and speed. So you need to create that vector. So that vector is going to have a direction that goes on that, circle that I was just talking about with Elizabeth. So it has a direction, and then it has that magnitude, that speed. So we can create a plane vector with just those 3 things. And then eventually we're going to add more things in to get a more, not more correct, but just a more reliable position. But that's the base. Our DR position is just a calculated position with those 3 things, course and speed, and then a known position. So why do we use our DRs? Anyone want to speak in? Why would we plot a DR position?
So we know, or we have an idea of where we are versus our expectations.
Yes.
Maintaining your direction.
Maintaining your direction. What else?
Plan a route in advance, schedule, figure out roughly when you're going to be somewhere.
Yep, get some ETAs, get some planning in. Those are all good answers. All right, so I have if we don't have anything else to get a position off of, we don't have a GPS, we don't have aids to navigation, we don't have anything to tell us where we are, we can use a DR position. And then for your predictions, intentions, projections, those are those, you know, getting an ETA, what am I going to be crossing in the next hour, projecting or predicting where you're going to be. I don't know why it's under here like this, but we use our 60D Street to put hourly DR positions on. So the book does say every half hour, but that is dependent on where you are. If you're in the middle of the ocean, every hour is fine. If you're in maybe more coastal waters where you want to be predicting where you're going to be more frequently, maybe you do a half hour. So that's dependent on the navigator. And then we always want to label that DR position correctly, and that's that half circle, and then the time is at an angle, so that we know that it's not an exact position. We got it just by using those three things. We didn't get it from GPS, we didn't get it from a visual bearing, from the radar, from whatever else things. The only thing that we put into this was our course and our speed. So we always want to label it so that anyone who looks at the chart knows that that's a DR position and not some other kind of fix. Okay. Oh, there's our label. Excuse me. Okay, so every 30 minutes or every waypoint is when we want to plot a DR. We also want to plot it if we change one of those three things that we need. So if we fix our position or we pass close to an aid to navigation, if we get a fixed position, we replot our vector. If we change our course, we replot our vector. If we change our speed, we replot our vector. So those three things that we need to create it, if any of those change at any point, then we replot. So because we are experts at 60D Street, that replot is going to be super quick. Yep, sure is. Okay, so this is an example of a plot. We have a known position at 7:30. We plotted a DR position. And this is our track line, what we're hoping to stay on, where in reality we'll probably be not exactly on the line. Does anyone know what it's called when you're not exactly on your I almost said it, when you're not exactly on your track line? That's going to be called cross-track error. If you have a GPS, that might give you a cross-track error readout, and that's going to tell you how far off your track line. Are you a half mile off, a mile off, 2 feet off, whatever it is? You can change it, but anyways.
Cross-track what?
Error.
Error.
And that's going to be abbreviated XTE. And that's going to be on your electronic navigation things. Okay. So that's dead reckoning. Now we're going to talk about getting more information about where we are. So we can get a ballpark of where we think we are with dead reckoning. But if we want some solid information, we need to start getting LOPs. And that's called a line of position. So a line of position is one piece of data or information that you're getting that has a time. So you're getting, I'm not going to say it yet, you're getting some piece of information at a certain time. And then what you get out of it is a line of position, and infinite possibilities along that line that you could be. You can be really close, or I want to draw this, sorry. New share. So if we have the most common line of position is going to be a visual bearing. So if we are on a boat cruising along and we see this light somewhere along this line, just seeing that light somewhere along that line tells us we could be anywhere along that line. We could be here, we can be here, we can be here, we can be here. We could be infinite possibilities along that line, infinite possibilities. So we need another piece of information, whether it's your DR to get an estimated position, whether it's another LOP, we need more information. All one LOP tells us is that we have infinite possibilities along that line. So what are some possible LOPs? Throw some out there that you can think of what can we get information of where our position is?
Using a hand-bearing compass off of a tower.
Yep, so that would be called a visual fix.
A visual fix.
What else?
Bearings.
Bearings, using the visual with your eyes. What
Yes.
other kinds of bearings can we get? Maybe if you have other electronic
Depth.
depth, yep, soundings or contour lines. We can use a radar and get a bearing using a radar, and there's going to be a list here, or range using radar. But anything else you guys can think of? Okay, let's get the list here. So we have our visual sight. That one is going to be our top one we're going to talk about in this class, and it's going to be the most trusted. You're going to trust by the book. You're going to trust your visual sights more than anything else. I like to say nowadays electronics are great and some maybe even better than your eyes, but
Oh, you're not going to use yet. I'm just changing your clothes.
So we have visual sight. That's going to be what we're talking about most in this class. And then we have our electronic range, radar range. So that's going to be using a radar, and the radar from the vessel echoes its signals to land, vessels, anything, and comes back. So the most reliable source, or the most reliable, are going to be your range from your radar and then your visual sight. When we're looking at these, let me go before we go. You can also get your electronic radar bearing. So that's just getting the bearing using your radar. A visual range, we're going to talk about that tonight, is when two things are in line with one another, whether they're offset or right in line. That's called a visual range. Loran-C, again, Loran-C is on our training chart that we see, but we are not using, it's not going to be used as an LOP in this class or a Coast Guard class anymore, but they are on the chart. And then we have our distance off calculations. We're going to do some bow and beam fixes next week, and we can use that distance off as an LOP, which makes it very handy for our quick fixes. Your celestial sightings, those can be used as LOPs. When you see the sun at a certain height or the stars or planets at a certain height, you can use that as an LOP. And then lastly, we have our contour lines, our fathom curve or your soundings. Those can be used as LOPs. So you want to see what you have on your vessel and what that information tells you. You might have this one little unit way down in the wheelhouse and you're like, I never knew what that did, but it's giving you information that you can get an LOP from. So you want to look around your wheelhouse and see what kind of instruments you have whether you have to bring them out by hand or use them in another way to get what they're telling you. Why are they there and how can they help me navigate? So when we look at these LOPs, a line of position doesn't have to be a straight line. If we use a range, that line is going to be an arc or a circle. So if I know that I am 2 miles away from the south point of this island, when I draw that on the chart, I can draw an arc that is 2 miles away from that point, and I know I'm infinite possibilities along that arc. And I think we did one of those in, did we do a range question already? I don't know.
How would I ever
Yes.
know how far I am from somewhere?
That would be using a radar.
Okay, so if I got radar,
Yes, I have not heard of a reliable way to get a range not using a radar. If anybody knows or has used a way, I'd love to hear about it.
but do most vessels have radar?
I would say not most recreational
Okay.
vessels. Some do. I don't know if it's not power versus sail. I'm not sure why some recreational boats have it and some don't. Depends on what you want on your vessel, maybe. I don't know.
Well,
And a lot of
now I
times,
know.
recreational boaters won't turn it on unless they're in fog or at night. That's real common. Yeah, okay. Okay, so we have the arc of the circle. Visual range is 2 objects in line. We're going to see an example of that. And then our contour line is a curvy line, whatever it is on the chart. So lots of little curves here and there. So let's look at some examples. So your typical bearing is from a buoy or a light or some sort of object, infinite possibilities along this line. So if you were on a boat here, somewhere on this line, you would be seeing that buoy at a bearing of 320. So that's in between your 270 and your 360. So that buoy is going to be northwest of you. You are somewhere along this line. Now we have a distance or a range. So if I know that I am 4 miles away from this point, I draw it as an arc. So infinite possibilities, 4 miles. The tricky thing with this, a lot of people have, is when you get a distance on a radar, a lot of times you use a ring that measures distance, and the ring is going the opposite way that you draw it on the chart. But I guess most of you aren't going to be using a radar anyway, so. Okay, we also have the range. If 2 things, a buoy, a spire, a point of land, anything is in line, you can just connect those 2 things and create a line of position. I like to say that the range, the visual range, is my favorite type of LOP because you don't need any instrument. You don't need a handheld compass, you don't need anything electronic, you don't need any instruments. You just need to see 2 things in line, whether it's the point of Dana Point and a buoy, or 2 buoys, or anything in line, 2 pieces of land. You can get a range that way. The last one in this image is a tangent line. Again, this is only going to be used for people using radar. And that's when you move your bearing line on the radar and it touches a piece of land just in one point. So tangent of a circle means the line just touches the circle in one single point. So that's going to be your tangent bearing, again, used by radar. Okay, so this is an example of a visual range. So a lot of times there'll be aids to navigation put in a channel to say that if you want to stay within this channel, these two ranges are going to stay in line. We don't have one pretty sure we don't have one entering Newport Channel, but there are a couple in the San Pedro, in the Long Beach, LA harbor for different approaches to different harbors within the harbor. So maybe, I don't know if you guys have sailed over there, you might have seen them. But this is another example of a visual range. We're cruising somewhere off the coast of Dana Point and we see two buoys in line. We could connect those buoys and I could say, I am somewhere along this line. I have at least one LOP. If I just connect these two buoys and then I just need one more piece of information to get a fix. So I could be, maybe I'm to the south, maybe I'm to the north, I don't know. But if I connect these two lines, I know I'm exactly on this line as I'm approaching Dana Point. So that's an example of a range.
So you're one of those points.
No, so you're not this guy or this guy. I guess I was supposed to.
Could you find your fixed position though, just using the two LOP points?
So I created an LOP just by seeing these two buoys in line.
Right, and you know that you're somewhere on that LOP.
Somewhere on that LOP. Now I have to get another piece of information to get a fix.
Okay. Could it be if you had a different bearing on your right or left?
Yes.
Okay, that makes sense.
Yeah, it could be any of those LOPs that we're talking about.
Or your depth. Your
Or
depth
your
is
depth.
always a quick one in that situation, right?
Yes, as you are approaching and seeing your depth change, depth's a great one, which we are going to look at in a second.
And this is you're comparing everything to your chart.
Yes, we are trying to plot a position on our chart so we know where we are. This is going to be a very common one for people who have radar, is a range and bearing from one aid to navigation. So this always comes in handy because you only need one aid to navigation. You don't have to have one over here and one over here, or two things that you're trying to connect and triangulate off of. You only need one thing to triangulate, which really isn't triangulating. But you can get two LOPs from one aid to navigation if you have an instrument that measures distance. So you can get a bearing and a range, and how that would look when you draw it on your chart is a line and an arc. So that's how you'd get a fix that way. These are your contour lines. So these blue lines, these are read in fathoms because this is on our San Pedro chart. So if you're approaching the isthmus, going in for a festival or something, and you're approaching, you can be looking at your depth sounder. If you see it crossing, 300 and getting shallower, you know that you're somewhere along this line. So if you get a single bearing and your fathom reading, you know you're somewhat, that would give you a fix. So really, as you're approaching a harbor, it's a great way to get a line of position by using these already plotted fathom lines. So you don't have to, draw in a curvy line. They're already plotted there for you.
Those are considered fixed points too, fathom reading?
So if you could see on here, this line is your 100 contour line. So it's 100 fathoms.
So you kind of have a general idea.
So yeah, so you want to be watching to see when your fathometer or depth sounder, whatever you have, crosses 200. It's a larger number and you're approaching and it's getting smaller. When it's 200, oh, it's 6:54. Now I have the time and the data point of 200 fathoms. Does that make sense? Kind of answered that question.
Yes.
Okay. What do we have? Okay, so one thing to keep in mind, and I think I put it on a different chart too. Two things I like to say, is that your bearing is not the same as your heading. So we talked about this a little bit 2 weeks ago, where your bearing is from your boat, from you to the object of interest is the bearing. Your heading is where your boat is pointed. So when we go to our deviation table, we always go with our heading, not a bearing. So we always use our heading at the deviation table. And we're looking at our bearings, so we could plot our bearings. The other one, I think it's on the next one, is that our track line is not an LOP either. So our heading, we might have drawn our heading in as our track line, but that's not an LOP. Let's talk about that. Okay, so these were all of our choices. Let's go back. We have, maybe there's more, probably. We have lots of choices to collect information, to create LOPs with infinite possibilities of where we are. Now, if we have 2 or more LOPs, that's going to give us a fix. So a fix is an exact position or a point on the chart. So it's a location, a position, a fix. Those are kind of the two things that I tend to call them. But it's an exact point on the chart. It's an exact location. And how we get that fix is 2 LOPs. So if you're infinite possibilities on one line, infinite possibilities on another line, and those lines cross, then I don't know, logic has it that you are where those 2 lines meet. So if you get more LOPs, the third LOP proves that the first 2 are correct. Or the fourth, or however many LOPs you can manage to get. And I like to say, I guess we'll talk about that in a minute. I think I make it dance. There we go. Your DR track line is not an LOP. So even if you draw one LOP out and you have a line that crosses it on the chart because that's your track line, you're like, oh, 2 lines crossed on the chart. That's great. The track line is not an LOP. We can't use it as that data point to get a solid fix. So we need 2 LOPs at least. Okay.
Because the track line is just a dream. Like,
correct.
This is where we're hoping to go.
Correct.
Right.
Correct. Okay. So steps on drawing a visual fix LOP is to, from your vessel, use your handheld compass or your vessel's compass to observe the direction, line of sight to an object. So in this case, I think it was approximately 320 degrees. So from my boat, 320 degrees from north, I see an object. Then draw to the object on the chart in the general area. So I could start my line down here and draw it towards the line of interest. Some people like to say draw it away from the chart. I find that a little bit confusing. So if we know generally where we are, and hopefully we do because we've plotted a DR, we can draw from our general area towards that light just like we see it. We're on the boat, we see it at 320, we're going to draw a 320 line. And then we label that line with time so that we know that if we have all of these lines all over our chart, we want to label them so we know what they mean and what they are, and someone else can come over and look and know what they mean and what they are. So a lot of times you can draw a dashed line from that point of interest or that aids navigation, and then where you think you are, you can make it that solid line. Once you get better at plotting positions and you want to have a cleaner chart, you can erase those lines, and once you get your fix, you can erase the other LOP's line. You just want those data points of how you got that fix logged in a logbook of sorts. Okay. Any questions on how we draw that visual line? Okay, so how do we choose an object to get an LOP from in regards to visual fixes? Any guesses here? Throw in.
Well, any buoy is gold, right? Like
Yes. Yes.
anything that shows up on my chart already.
Exactly. It has to be plotted on the chart. What else?
How about fixed versus, and then I would say lighted might be helpful in case it's at night.
Yes, fixed versus buoy, or fixed versus non-fixed, or if you're at night, lighted versus non-lighted. All right, those are all great answers. So our number one, it must appear on the chart. So if we are navigating at night and we see this big bright light on the coast and we're like, yep, got a solid bearing from that, feel confident about it. But I misidentify what that light is. Maybe it's a stoplight, maybe it's a construction light, maybe it's just a regular house light, floodlight or something. Then it's not on the chart. I can't get an LOP from it because I don't know exactly where it is on the chart to draw that line from. So most of the aids to navigation are going to have those characteristics. Is it green? Is it can shaped? Is it what shape is it? What color is it? What light characteristics does it have? We want it to appear on the chart, and we want to correctly identify it so we know what we're looking at. And then our second one, we want to have a good triangulation, if you will, have widely spread aids to navigation. So we have a better cross, or if our cross is too close to one another, it has a larger room for error. If these two lines are very close, maybe I can do it with pencils. If our two lines are very close to each other, we have a larger room for error versus if they are crossing one another. So our rule of thumb is 2 LOPs, you want approximately 90 degrees from each other. 3 LOPs, you either want it 60, so these are 60 from each other, or 120. This one is 120 from each other. Here on the West Coast, most of our aids to navigation are going to be on one side because we're not doing a lot of intercoastal waterways or anything. So it's mostly going to be all on one side. It's going to be very tough to have 120 degree range of your aids to navigation. And then you can also ask which one is changing fast. So which LOP do I want to take first or depend more reliably on? Is which one's changing faster? Anyone know which one's changing faster? The ones on the beams. So if it's closer to the beam or the side, as you are moving, that bearing to you changes rapidly. As you're moving forward and there's an aid to navigation closer to the bow or closer to the stern, those are going to change slower. So if you want a 8 o'clock position and you have a lighthouse off your beam and a buoy ahead of you, you want to get that lighthouse first at 8 o'clock because that's going to be changing much more rapidly than the one closer to in front of you or astern of you, because that's not going to be changing as you are approaching it. Well, it will be changing a little bit, but not as quickly. So you can keep that in mind on kind of weighting these LOPs. Like, I'm going to depend more on this one or put more weight in this one when I get my fix. Because most of the time, professional navigators, commercial navigators, everyone are going to get not a pinwheel. So if they all cross exactly at the same position, you have a great fix, and that's called a pinwheel. What most of the time happens is we get a triangle, or maybe a weird hexagon, or however many quadratic or something, however many LOPs we get, that they don't exactly cross at the same exact point. So we want to decide where we are. We can say we're in the middle, or we could say, hey, maybe that blue line that I got there wasn't really reliable. It was a buoy, it was floating, the other two were fixed, or I was unbalanced when I was getting it, or whatever it is. You as a navigator can put, weight or judge where you're going to say you are when you get this triangle. This triangle by the book is called a cocked hat. But it's basically a little triangle, but it's called a cocked hat. So you as a navigator can decide where you are. Now, if there's some sort of danger or something along the way, you always want to err on the side of caution and say, out of all of these possible positions, I am close to that danger. So then I can navigate away from it or take appropriate action not to hit that danger, whatever it is, land, whatever it is. So if you get a cocked hat, which most of us will, you can use your own judgment as a navigator. It is the art of navigation, or err on the side of caution, wherever that caution is. Does that make sense? So far, so good? Okay. Okay, that was our quick lecture today. Now we're going to get into it. Any big questions? Okay, let's take 5 minutes here and get your training chart out, the Martha's Vineyard sound chart, and assignment 11. I will readjust my camera. Hold on. Okay, so you guys have your charts ready? All right. All right, are we ready to go? I guess that wasn't exactly 5 minutes, but hopefully we have our charts out. This is going to be the, what is this? Rhode Island Sound here. We're going to start down south of Martha's Vineyard. Martha's Vineyard, Gay Head, No Man's Land Island, Southwest Shoal. This is the area we're going to start. So on the chart, I'm looking at assignment 11. It tells us we are southwest of No Man's Island at 8 o'clock. Describe the buoy that we see at latitude 41 degrees, 12.2 north, longitude 070, 50 west. So 07050 is right on a dark bold line. And then my 42 approximately is going to give us about 2 miles. So we're looking at this light right here. So this light is a buoy or a non-lighted buoy?
Lighted.
Lighted, yes. Okay, so it tells us this first two. First, it tells us the shape. It has an open circle, so we know that it is not fixed. This is a buoy, not a light. Then it has this magenta stamp over it, and that tells us it has a light on the buoy. So it's a floating buoy that has a light. This first line here describes the physical characteristics of the buoy. So the buoy itself is red, and the buoy has a number 2 on it. Whatever it is in quotes is what you're going to see on the buoy itself. So that buoy has a number 2 on it, and it's red. This section describes the light of the buoy. So it is flashing red every 4 seconds. And then it also has a whistle. And it actually says whistle. I just ran out of room. So that is what we are cruising around. And from that buoy, we're at that buoy at 8 o'clock. From that buoy, we plot a DR course. So we're hoping to head, we're kind of creating a little track line here. A course of 294 at 6.3 knots. So I'm going to use the roll plotter first, but I will do it one triangle as well. So I'm going to look for 294. So here's 270, 80, 90, 294. Line that up. Got it just right there. I'm actually going to use a big pencil so you guys can see it. There's a big line. We're going to draw in our track line or a DR line. If you're using a triangle, if I have the triangle like this, I run out of room. So I'm going to flip it over and use it. I like to put my pencil on my starting point. So I have something to pivot on. So it's a little bit easier for lining things up because I have a pivot point. So I'm lining up that focal point on the vertical line and then 294 at the top. So here's 290, 294. Oops. 296, 294, right there. So I can draw in my line, move my triangle a little bit, and continue drawing my line. With the parallel, we get 294 on the parallel ruler from the compass rose, and then you just bring it down. I did not do it right. There it is. To our buoy and draw in our line.
Can you review, are we writing 294 at
Yes.
6.3 knots under the line?
So I like to write 294 on top of the line with a speed of 6.4 knots on the bottom. That's typically how I'll write it.
And you're gonna write that close to your departing point.
Yes. Sometimes if you have a big line, I might do something like this. 294 degrees true, so that I can plot my fixes along the way, but I know that this whole line is 294. So I kind of line with a little arrow. That's another way to do it.
Gotcha.
I like to put it right where your turns or waypoints are at the beginning, so that when if you're approaching this, buoy, so that you know what the next course is. And then you can see this whole course is going to be 294. Question. So we have plotted, and then it says mark and label your 8:30, your 9 o'clock, and your 9:30 DR positions.
Assuming we're going straight on this, straight away.
Yes. Yes, that's what we're assuming. So if we maintain a course of 294 at a speed of 6.3 knots, because that's what we think we're doing, where are we going to be at 8:30, 9, and 9:30? So I have a speed of 6.3 knots. I have a time. I'm trying to get my position every half hour. So my time is 30 minutes. I don't have to change that. My distance is my question mark. So I have D equals S times T divided by 60. D equals 6.3 times 30 divided by 60. What is my distance?
3.15.
3.15 nautical miles. So on my dividers, I'm going to find 3.15. I know it's off the camera here, but
So 3.15
I know.
nautical miles will be your first time reading.
Correct. So I have 3.15 on my dividers here. So I'm going to start at the buoy. I was at the buoy at 0800. I think I'll be here at 0830. I think I'll be here at 0900. And I think I'll be here at 0930.
So Captain, you could have, the 294 could have come off your compass at my heading.
Yes, that's your heading.
That came off of looking at my compass.
Yes. So as you are steering your boat, you can either be steering by something far in the distance, but if you can't see something far in the distance, you steer by a compass reading. So you're trying to maintain your lubber line, which is the line that stays with the boat as the boat moves around the compass, in line with 294.
You'd have to convert to your magnetic to do
Yes.
that. Okay.
Yes.
So what we're really, this 294 is a well, it's saying true on the
True.
ours.
Yes. Anything that we plot on the chart is going to be in true.
But it's not really true. It's because magnetic is what we're.
So what we'll see, I don't know if we'll do it on this one, but we'll definitely do it on the next assignment, is I'll write 294 true, and then I can also write, 301 per standard compass. So you have both what you're actually steering and what you're actually going. I just made up that 301 because I don't have a made up thing for that right now.
Could you
Okay,
just take your variance on your compass rose?
Yes, and then you also apply your deviation. So I guess
Okay,
yes, we
all right.
can create what our compass heading will be.
But the compass is giving me true.
No,
Compass is giving me magnetic.
the compass on your boat is reading magnetic.
But I don't put that on the chart.
Nope, you have to put it in true on the chart. Okay. I'm pretty sure we're going to come up with one of these. Okay, I guess not on assignment 11, but on assignment 12, we definitely are. Okay,
This is going to be 40.
what are we doing here? Your 9 o'clock DR position, what is it in latitude and longitude? So this is our 9 o'clock DR position. I want to get the latitude and longitude.
12 minutes. And then my longitude is going to be
So what am I doing here? For my latitude, I got 40, 41, 14.8, 14.9. I got 14.8, yeah. And longitude across the bottom here, 55, 56, 57, 57.7. 57.6, I got 57.7, close enough. Is there a potential problem if you stay on this course? So
Is that
there is this right here, this unexploded depth charge with an estimated date of September 14th, 1957.
It's ready to blow.
Ready to go.
Probably be fine.
Yeah, I think we'll be all right. But maybe we want to avoid it if we can. Who knows?
Did they
But-
ever go off?
I mean, they did at one point, but
You don't want to
that
find
is the object that we are going to try to avoid. So it says, is there a potential problem? Yes. And again, remember, anytime we draw a line, we look along that line for potential problems or hazards. So is there a wreck? Is there a shoal? Is there land? Are we crossing a traffic lane? What's going on? What is the position of this unexploded depth charge? So again, we are, maybe I'll use a different tool. We are practicing what's our latitude and longitudes. So what is the position? Using parallel rulers.
Of the bomb.
Of the bomb. Get our latitude. Team 17.0. Yep, 41, 17.0. 71, 4.0. That is our position for our depth charge. Okay, now this is what we're practicing here. Getting a fix or plotting two LOPs. So they told us at 9:15, so we think we're somewhere in the middle between 9 and 9:30. So if I was going to guess, I'd say I'm somewhere around right here, ballpark. You observe the following bearings: Gay Head Light at 050 and Buzzard's Light at 340. Determine your 9:15 fix and label your LOPs. So we have Buzzard's Light right here, and then we have Gay Head right there. So I'm gonna use the triangle first. I like the triangle. Buzzard's Light, I'm gonna put my pencil on Buzzard so I have something to pivot on. And Buzzard's Light was bearing 340. So I am going to, Buzzard's Light is bearing 340. Looking for 340 down here. All right, 340. So now I can draw a dashed line, and then somewhere crossing my area where I think I am, I'll draw a solid line. So I think I'm somewhere along this line, but I could be anywhere. So I kind of did dashed and then a solid line. For gay head, I am 050. Put my pencil on it, find 050. It's not gonna reach, so I'm gonna move it down the line a little bit. There we go. I can draw dashed, and then, oops, I wiggled. So you guys are gonna wiggle like that. As we're drawing lines, I wiggled a little bit, so you kind of have to go back and remeasure. But that will happen. Don't get too frustrated with yourself. Be lenient. The more you practice these plotting skills, the better you'll be at it. So keep practicing.
So how did you get those big, I don't know how you could make those two lines.
Okay. What plotting tool are you using, Elizabeth? Are you using this one?
I'm using the triangle.
Okay. So on the triangle, I put my pencil on the light.
On the light.
Yep. And then I put the focal point, and then I'm looking for 340.
Well, that's my question. Where'd you get that number?
In the question, it says Buzzard's light was bearing 340 degrees true. It's a given data point in the question. So they're saying, as I'm cruising along in my boat, I got a bearing to Buzzard's light. I don't know what that bearing was. I somehow converted it to true, and that's what the problem is giving me. It's already giving it to me in true.
Okay.
Captain,
Just an exercise of plotting these LOPs. Yes?
Captain, you mentioned briefly in that prior monologue focal point, and then I don't think you used the focal point. Can you rewind that and say that again?
Yes. So here's our focal point.
Uh-huh.
So I put my pencil on the light.
Yep.
And then I want to line up the focal point and 340 on a vertical line.
On a vertical, okay, that was, okay.
So I'm using the vertical line for 071 degrees longitude. So I have a line on my triangle here from the light, focal point, and 340. So anywhere along this line is 340.
So Bree, if we're using dividers, then we still line up at Buzzards Bay Light, and then we just walk over to the compass rose to 340?
If you're using these guys?
Yes. Parallel
Yes.
rules, I'm sorry.
So we get 340 on the parallel rulers.
Yep.
So I have 340, and then you walk this guy. I'm hitting my camera here. There we go. Right until it gets in line with the light, and then I draw from the light. So you can do dash, dash, dash somewhere, 3 to 4 inches where you think you are, solid line. Same thing for the other guy. What was this? 050. Bring it on down, dash, 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 solid crossing. So with these two data points here, we have two infinite possibilities of where we are. Let's see. We have infinite possibility along this line, infinite possibility along this line. So where those two lines cross is going to be our fix or our position. So it's tempting to say I'm somewhere within this triangle, But remember, this track line is not a line of position. We only have 2 data points here. So wherever these 2 lines cross is our 9:15 position. It asks us to get the latitude and longitude. Use another tool here.
And we can't rely on our track line because of that error you talked about?
Because the track line only is a prediction. A prediction. All it is that known position of where we were, and hopefully if we're in autopilot or we have a really good helmsman, we're maintaining our course, but most likely we're, you know, not exactly on course. So, and there might be wind and current and all that stuff. So ballpark is we want to be on this line, but I think next week I'm going to go, maybe it's the week after that. I don't know where my thing is. We're going to go into estimated positions. So estimated position takes into account your DR position and that track line and 1 LOP. Hopefully that'll make a little more sense for you.
So you're putting a lot of trust in these 2 bearings.
Correct.
More than your track line.
Yes, so you're just cruising out there in the middle of the sound here, and you last knew you were by the buoy an hour and 15 minutes ago. You think you've maintained a good heading, but who knows? And you say, okay, I want to know where I am. So you get your compass out and you say, I got a bearing to Buzzard's Light and I got a bearing to Gay Headlight. Where those 2 meet, that's where I am.
Okay, so that's good information. That's accurate.
Yeah, so it's irrelevant of what your course or track line is. Like this checks out that yes, you know, I thought I was going to be somewhere in the middle of these 2, and that's pretty close. You know, I'm not like up here or something. Like if I'm within, I don't know, 5 miles, then all right, I'm pretty good. So that's our 9:15 fix. So from here, we get another question first. What is the depth of water at your fix? Anyone?
About 130 feet.
Yep, 130, 133, something around there. Okay, now it asks you, are you on your DR track line? No, we are not, right? We have fallen off course or off track line. Are you to the right or to the left of track? So this is where it gets to be up to you as the navigator. Do we want to stay on this track line? Is that really important to us? If so, we find ourselves over here, then we need to come to the left to get back on our track line and continue on, hopefully maintaining our track line. Do we not care about that road? It was just an imaginary road that we put on the chart anyways. So do we just continue our 294 from our known position? Every time we get a fix, we have to then plot our DRs again, because now we have a new known position. So it's up to you on what you want to do. I would say most recreational boaters don't really care about getting back to that imaginary road. Most commercial boaters steer back to the imaginary road. Again, it's imaginary, doesn't really matter.
But I would have known I was off course because my compass would tell me. Or no, it wouldn't have, because parallel. I'm
Yes,
parallel to
so
that.
you could be steering 294 this whole time, but it can be pushing you slightly off course.
Yeah, okay.
It doesn't mean you actually went that way. So you're over ground, and that's what we're going to look at right now, is from this point to this point. But if you're an autopilot or you're steering, you were trying to steer that 294 true. Okay, so we are at this position at 9:15. We were at this position at 0800. Trying to make it so you could see on here. So these were our two fixed positions. All of these other ones were DRs. Those were just our calculated guesses, if you will. So it asks us, what was our actual speed from buoy 2 to our 9:15 fix? So I'm going to connect those. And I'm going to measure the distance. So they are asking us for speed. That's the question. So I need to know what my time is and what my distance is. So to get distance, I'm just going to get the distance between buoy 2 and 9:15. Hmm. 7.1. I guess it was closer to 7.2. Oops.
You bring
And
it
then my
down slightly
time.
there.
What?
I couldn't see your erase pad there, sorry.
Oh, sorry. Are you saying, should I do it like that? You guys can still see it. Yeah, I'll do it like that. Okay. Speed is my question. Time, distance, 7.2. So I have calculated this distance to be 7.2 nautical miles. And then what was my time? So if I'm drawing it on here, here's my buoy 2 at 0800. And then here is my fix at 0915. Now I need to get my time difference. So I always do my later time on top. Minutes first, 15 minus 0 gives us 15, 9 minus 1, 1. So I have 1 hour, 15 minutes. I convert that to minutes because we're going to minutes. So I get 75 minutes. So now I have my formula. And what do I get for speed?
5.76 knots.
5.76 knots, so about 5.8 knots. So I am going slower, right? I thought I was doing 6.3, but I'm doing 5.8. So maybe there's some sort of current or wind. I'm not making as much speed as I thought I was. Okay.
Captain, quick question.
Yes.
If you were going commercially and you wanted to get back on your original track line,
Mm-hmm.
you would figure out what course you needed to, and you wanted to be back on your track line in by 9:30. You literally just draw a line between your fix at 9:15 and your DR plot at 9:30, figure out what course that is and steer the boat to that.
Correct.
And then if all of that goes right, when you take your fix at 9:30, you're right back on that line.
Correct. Now, this is kind of going to be a little bit out there for some of you, but hopefully I have on some sort of waypoint like up here or something. So on my GPS unit, you'd have a waypoint plugged in, kind of where your next turn is on your track line. So I guess let's draw a track line. Here's waypoint 2. Here's waypoint 1. I got a fix around here.
Yep.
Right? So this distance here is our cross-track error. Excuse me. How far am I off course line? So are you okay with being a quarter mile off course line? Are you okay with being a mile off course line? Depends on, you know, a quarter mile is pretty good. For recreational boating, I'm sure you'd be a little more accurate than that. So you always kind of want that to be 0, and how you maintain that, because something, if you're steering 294, something is pushing you this way, right? So you want to keep adjusting your course so you maintain your track line, but your heading is going to be a little bit different.
Yep.
So on your GPS, you have typically a bearing and a course made good. And 4, my bearing to that next waypoint is going to be less, right? It's going to be, I don't know, 280. My course that I've been doing has been more than 294. It's been, we'll call it 300. The difference between these two is how you want to adjust your course, because ideally you want these two numbers to be the same.
Yep.
Your course made good and the bearing, because that means you're on the quickest possible route to your waypoint. So I would adjust, I would come to the left 20 degrees in this case. But usually it's much smaller margin than that. It's like come to the, you know, adjust your autopilot or tell your helmsman or something, let's come over 4 degrees. Let's come over 6 degrees, 2 degrees, whatever. Usually it's a toggle. So it's, you know, 2 to 3 degrees at a time. But
And we got to make up 10 degrees.
20.
20 degrees, yeah.
This is an advanced way of thinking about it, but hopefully that answered your question, Patrick.
Yeah, no, I'm good. It's you went into more detail, but my intuition, I think, was right in that you basically got to replot and then go,
Yeah.
okay, until we get to this next data point, steer to this to
Yeah.
get me back on my DR plot.
So you're looking at your cross-track error and then, yeah, bearing and course made good.
So that,
Okay.
that movie that just came out with Tom Hanks, I think it's called Greyhound or Grey. The whole movie was this.
Was it?
Bearing 2 degrees, 4 degrees, 8
Yep.
degrees. That's the whole movie.
Yep. I haven't seen it. Haven't been to the movies in a while, but I'd like to.
Yeah, that was the only dialogue in the whole movie, it seemed like.
That's funny.
So what you were talking about, would that be like if you had a tide or a current pushing you?
Correct. And in reality, that's going to be happening, right? We're going to have something, our heading is not going to be the same as our course made good.
But it's also something pretty predictable, right? That we'd be able to.
To a point, yes.
Yeah.
And there's wind.
And there's wind. So CoNav1 is what we're going to talk about. All of the set and drift, calculating tide and current, correcting for tide and current, or correcting for current, and correct for tide. But yeah, that's what we're doing in CoNav2. Okay. Okay. We haven't quite finished yet. I got ahead of myself. Last question. Can you continue on 294 true for a while without any charted hazards? So here they're saying, if I stay on 294, am I on 294?
No. That was our new course.
If we continue steering our plotted 294, so we're basically paralleling the old course to our new position. If we don't steer back, will we miss this hazard that we were going to hit before? And if we continue steering what we are steering, we'll probably continue our course made good line and end up even further away. So I feel like that's a bad question, but I don't know. So again, this is up to you. Stay on your line, or every time you plot a new position, you plot a new DR. So if we're still steering 294, we plot our new course line, put a new DR. Projection out. I think I'm going to be over here at 0930. I didn't actually measure that. I'm just plotting something.
So in reality, are people using GPS coordinates as their fix while they're, for example, if you're operating a sailboat, number one, you may not be able to stay on course depending on the wind. And then you've got leeway depending on how efficient your boat is. And if you're taking, to try and, obviously, if you're going to try and shoot your position while you're sailing, you're going to be extremely busy.
Yes.
So what do most people do?
I'm not a recreational boater, I'm not sure, but even in the commercial industry, most of the time people just use GPS. It's good to check it. So you always want to verify that your GPS is working. So maybe you get 3 fixes with GPS and then 1 fix using visual bearings. And then 3 more fixes GPS, 1 fix with radar. You can see, like, am I way off on my radar or my visual? Maybe I need to check my GPS. But these days, GPS is very accurate. And if it's not accurate, it's usually giving you a warning, telling you, I have a bad satellite signal from this one. I have an error over here, that it's usually telling you that it's DRing, meaning it's lost track of the satellites. Or something is happening with it. So I'm going to say most GPSs will do that, but again, everyone has a different price point on their GPS and that kind of thing.
Yeah. Okay, thank you.
Okay, well, let's take a 10-minute break, or 8 o'clock break here, and get out the San Pedro chart. And we'll be back in 10 minutes. We're going to do assignment number 12, the 3-day cruise. All right, I'll be right back. How's everyone doing? Cool, cool, cool. All right, well, usually in class, I let everyone start assignment 12 and I walk around to work with you guys individually. So feel free to move ahead and go as fast as you want. You don't have to follow along with me or anything. I'm gonna do day 1 with you guys, and then kind of just be on standby for the next hour or so. If you guys want me to do another part or another number or something, I'd be happy to. Again, all of it is on the YouTube video, and the numbers are at the top of the screen. So if you get stuck on number 9, you don't have to watch the first 1 through 8 problems. You can just skip ahead to number 9. So hopefully that helps too. But yeah, we'll get started with you guys, or I'll get started with you guys, and then kind of see how things go, I guess. We'll see. Okay. So assignment number 12 is our 3-day voyage. Leg 1 is from LA Harbor to Newport. And then we go Newport to Avalon. Then we go Avalon back to San Pedro. So our first leg, we plot, and then we get a position along the way, we correct, etc., etc. Each kind of day we have our own different little challenges. And I'm pretty sure, maybe not. I guess on day 2 and 3, we'll go more into the compass error, back to that compass error. But I think on day 1, I make it easy for you guys and keep things in true, just to ease our way into this. So let's get started. Day 1, plot a course from LA Buoy 6 to the NWP buoy. Departure time was 12:45. A brisk wind will ensure us to sail a direct course at an average speed of 5.5 knots. Great, so we want to plot that information. So first we want to correctly identify each buoy that we are going to. So buoy 6 in LA, this is the LA side of the harbor. Here you have your Los Angeles light. Here is the Long Beach side of the harbor. So here's, kind of goes like this. This is Long Beach, this is LA, even though it's not LA, it's San Pedro, they call it LA. This opening in the jetty right here is called the Queen's Gate. This opening in the jetty is called the Angel's Gate. So if you hear people, cargo ship or something on the radio, say they're going to be, exiting Queen's Gate or exiting Angel's Gate, just good to know what they're talking about. So we are in the LA side, meaning San Pedro, and we're looking for buoy 6. So we've come out of the harbor, here's buoy 6, and then we're going to take a turn to the east and head directly to Newport. So I'm going to connect the lines. Luckily my ruler reaches, but you can use a roll plotter, use whatever you need.
So you're just plotting to the end of the harbor there in Newport?
To the NWP. Is it not on the So this safe watermark, this buoy,
Okay, gotcha.
is NWP.
Buoy 6.
We're gonna be using that a lot. Sorry, I kind of assumed we knew where it was. Yeah. That's our safe water mark, marking the entrance to the Newport Harbor. So anytime we draw a line, we check that line to make sure we are good to go. So we can see what our depths are. We're going to be crossing a pilotage area, but we're leaving Los Angeles, so it's probably pilot areas there as well. We're going to be crossing a fishing haven. That's okay. We have a little wreck over here. Might need to be looking out for that, but it says it is 8 fathoms. So what would 8 fathoms be in feet? Pop quiz.
48.
48. So if our draft is less than 45, less than 40, we're probably good. Our draft as a recreational boater, I think we'll be all right with a 48-foot draft.
What do they mean by a fish haven? Is that like an area where you're not allowed to fish? Is that an actual obstruction?
What is a fish haven? I want to say that you're not allowed to fish there. That's my knee-jerk answer, but I'm not 100% positive.
Yeah. And then that area directly south of there, which is the Monet Farm, is that an actual floating fish net where they're doing marine farming of fish?
Yes.
Yeah, okay. I didn't know they did that around here.
Yeah.
Google says it's a artificial shelter made of rocks, rubble, subway cars, airplanes to create a place for the fish to thrive.
So it's, I guess, maybe a shallower area.
Is there a depth on there or anything?
It says authorized minimum is 10 fathoms, 60 feet. So generally in this area, you'll have a rough bottom, but it authorized minimum of 10 fathoms. Good. Okay, so we plotted our line. I'm going to write on my line. Oh, I haven't figured it out yet. What is my true course? So we could use any of the vertical lines if you are using a triangle, or you can use, where did they go? A roll plotter.
11.
Bring it down. Oh, it has to be like this. So somebody said it, 111. So we have a course of 1110 with a speed of 5.5 knots. What is the distance of this entire leg? So it's a long leg, so I'm going to get on my dividers, 5 nautical miles. And then I'm going to walk those dividers. So I have 5, 10, 15, shy of 15, or shy of 20, excuse me. So 15 plus 4.4, so that would be 19.4 nautical miles. Good even right. I have a distance of 19.4 nautical miles on this whole course, or this whole leg, course. And then it says plot your DR for hourly positions. Did it give me a departure?
Yeah, 1240.
Oh yeah, it did. Okay. So I departed at 12:40. When will I be there? Or it says plot our hourly DRs. So my first DR is going to be, I have a course of 111 true, a speed of 5.5 knots. So I need to plot my first DR at 1300. So 13, okay, that probably doesn't work. 1300 minus 1240 gives me 20 minutes. So I have a time of 20. I have a speed of 5.5. What is my distance? Anybody get the distance?
I don't know.
1.32.
1.2?
Oh, sorry, 7.32? Or
And
7.3?
20 minutes?
No.
No.
Yeah.
Can you show me how you're solving for D? 60 D equals S times T?
D equals S times T
1.8 nautical miles.
divided by 60. .5 times 20 divided by 60. .5 times 20, 60. 1.83 nautical miles. That makes more sense. Okay, so now I can mark 1.83 nautical miles. And I could plot my 1300 position, my DR.
What question is asking us for the 1300? The wrong question.
So it told us to put our hourly DRs.
Oh, okay. I missed that.
So yeah, right above number 3. So we plotted our 20 minutes out to 1300. Now it's going to be really easy. You get 5.5 and you just kind of walk it. I think it's like that. 5.5, 5.5, 5.5. So you have your 1400, 1500, 1600. So we had to calculate our first little section of the DR, but then our hourly DRs after that are relatively easy because our speed is in nautical miles per hour. So in 1 hour, we would travel 5.5 nautical miles. . And, okay, so I guess let me plot that so I can show you on here. So these DRs help us do that predicting. So if, you know, maybe I had a friend or a relative or something hanging out on the Huntington Pier, the Huntington Beach, say, oh, I'll be cruising by at, let's call it 14:45, right? Here's the Huntington Pier. I'll be cruising by before 1500, after 1400, roughly 14:45. Or when am I going to be crossing this fishing haven? Roughly about 1400. So it kind of just helps having those hourly DRs to kind of anticipate your ETAs, not necessarily to the end, but to little points along the way. Maybe you're crossing a traffic lane, or you have a you know, radio check-in point that you need to do, or something that or maybe a boat asks you, hey, what's your ETA past the Eva oil platform? Like we're doing some work around there or something. That way you can, instead of say, oh, hold on, I have to do 60 D Street real quick and take 5 minutes to do something, you can just quickly, oh, I'll be around Eva platform 14:15, give or take. It's just a quick way to do that predictions, if you will. Okay. So we put on our hourly positions. What did I say? What position will your 1400 DR be? So you get your latitude and longitude. Gonna trust that you guys can do that. What is your ETA to your final destination? So again, looking at this, I have a 1600 and then a little bit more. So I might say about 1615, 16, not quite 1630, you know, give or take 1615. But to do it accurately, if you will, we had a distance of 19.4 nautical miles. Excuse me. So we can use our, oops. We want to know a time. So it's our question. Speed is 5.5. Distance is 19.4. So I have 60 times D divided by S gives me T. You get a time of 200, we'll call it 212 minutes. So what does that equal in hours and minutes?
3 hours 32 minutes.
3 hours, 32 minutes. So then, if we departed at, let's say, we departed at 12:40 and we had 3 hours, 32 minutes. We get 72. 72 doesn't work, right? So we have to carry over a 1 and we get 12. And then we give 12, 13, 14, 15, 16. We have 1612 as our calculated answer. And I said approximately 1615, so I would say an ETA of 1612 makes sense. You always want to do that common sense check. Does this make sense? Does it make sense to you guys? Any questions? Okay.
1,600 hours,
12 minutes.
4 o'clock, 4:12.
Yes, 4:12 p.m. Okay, then it asked us, were there any hazards along the way? We saw that Fish Haven, they're coming up with this wreck that's at 8 fathoms. This Fish Haven's at 10 fathoms. Again, not a big deal for us small draft people. What's the typical draft of a sailboat? Anybody know?
6 feet.
16, 20 feet?
What?
6 feet.
Yes.
Yeah.
Yeah.
4 to 6 feet.
8 feet.
6
Draft
feet.
sailboat. 6. Yeah.
Okay, that's gotcha. Pretty shallow. Okay, so 8 fathoms, not going to be a worry for you. Okay, at 1400, you believe you might be off track, so you get a position. You observe 2 aids to navigation, the tank of Anaheim Bay on the Naval Weapons Station, and oil platform Eva. I've made these very easy, or I didn't make this, somebody else did. They made it very easy bearings, 090 and 000. So that's due north and due east of these 2 aids to navigation. What is our fix? So let's locate those. So this is our Anaheim Bay Naval Weapons Station, or this is Los Altos. Here's the Naval Weapons Station. So here's the tank that we are looking at. And then we have Eva here is our oil platform. So 000 and 090 are both due north and due east. So if I was doing it quickly with a triangle, I could just line up that triangle with my tank and put my perpendicular line on a latitude line, and then I would know that this line is pointing due north, just like our latitude, or plotting our longitude lines. So you have a longitude line, you roll it over to the tank, you plot it, or you go to the compass, 000, due north, just like our longitude lines, bring it over to the tank, draw your line. Same with our latitude. and we're going from Eva so we have a cross. I'm going to erase that number. Okay. So we have a cross right here. So this is our 1400 position, and this was our 1400 DR position. So we thought we'd be here, but we ended up over here. So we did end up off course, which is what's most likely going to happen. So what does it tell us? Are you correct? Are you off your intended track? Yes. Are we to the right or left of our track line? So to that right or left of the track line helps us in, should we change course to the right or left? So we are we to the right or left? Where's my boat? We're cruising along. We are to the left of the track line. So we need to change course to the right to get us back on course, if we want to go back on course. But at this point, it asks us, what is the course from our 1400 position to our bearing? So we're going to go from our 1400 to our buoy. Drew in a line there. What is our new course? You guys can't see it. You guys tell me, what's the new course?
I think it's 115 degrees
Yep.
true.
115, 114, something around there. So we came to the right. Couple clicks, 3 clicks to the right. Now it asks us, if we keep on this new course, what is our new ETA? So our distance from 1400 to the buoy is going to be a new distance, right? So we're still going to use, we can put on our course 114 degrees true, speed 5.5. What is our ETA?
Hey, Captain, I think we're going faster than 5.5.
Yes, I would agree. I would agree with you on that.
So do we use the 5.5 just to keep the math easy, or are we assuming we're at the same speed we went from 1240 to 200 to 1400?
We're going to use the 5.5 to keep things simple right now. But when we go to CoNav1 and we talk about set and drift a little bit more, we'll be taking into account our new speed.
How did you know we were going faster?
Our 1400 was a little bit behind our 1400 DR in compared to our 1400 actual fix.
I see.
Is a little bit further. So you could actually, never mind. We're going to go into that in a couple weeks.
It could be a difference in distance, couldn't it?
What was your question?
Could we have cut the corner a little bit?
Cut the corner.
Well, is the distance that we thought we were going to go and the distance we actually went different?
Yes. So,
So I was saying, if you cut the corner on that bay there, that would cut your time down. So it's not just speed, right? It could be distance that made it shorter time.
yes. So we wanted to go shortest possible route from, buoy 2 to buoy NWP.
To the end.
We've drifted up over here. Let's make this a lot accurate. We've drifted here at 1400 when we thought we would be here at 1400. Oops, too many zeros. So we've made a little bit better speed because we've gone farther than our anticipated track line, but we've also been pushed pretty far to the north, which is closer to our coastline. So we would rather drift away from our coastline or away from dangers than toward the dangers, if it's that uncontrolled drift or unanticipated set that we are getting. So basically, I guess I'm going into this. There's a little triangle here. And we go dive into our navigation triangle in the next class. This is what our boat was doing, right? Our boat was cruising along at that heading, at that speed. This is what we thought we were going to do. What actually happened, we were here, and then we ended up here. So this would be our made good. Our speed made good, our course made good. What actually happened, this is where our wake went. So even though my boat was pointing this way, it was actually going along the made good line. Our last line is our set and drift line. So I can calculate what my current and my set and drift are from calculating that line using our 60D street. But we're going to go into that later date. I'm just complicating things for you. But keep on working.
Captain, can you remind me where we find the variation for this area?
Yes, variation is going to be on the compass rose.
Oh, that's right. Thank you.
In the middle of the compass rose, it says 12 east, and then it'll say that annual increase or decrease. And those are in minutes, and it's so small that it really doesn't affect ours one way or another. So 12 east for variation is fine.
Thank you.
Yep.
Hey, Bree, when they're asking here for the course to steer per compass, after we apply the variation, should we use the deviation table as well?
Correct. Yes.
Okay.
So the only time you don't do deviation is when you have a handheld compass getting a bearing. But in most of our questions, we are not using a handheld compass. We're using the actual ship's compass.
Okay, thank
So
you.
we'll be applying deviation.
Thank you.
Are you there, Captain?
Yes.
Okay. I'm off a little bit on my entry of the traffic lane. Question 16.
For your time.
Yeah, and I'm not sure why. I have, and maybe this is, well, I'm going from my, my dead reckoning point at 1 o'clock,
Mm-hmm.
so 1300 is, oh shoot, I'm not sure how we're going to get this. Do you have the math behind your, the answer to 16? You know, the 60D Street math?
Let me look. Hold on a second.
You know, did you look on the chart? The traffic lane starts a mile sooner than I thought. 1 nautical mile sooner. So it looks white, but it's
Oh,
actually
it's the dots.
Yes, yes. That
Oh.
purple is the separation zone, not the traffic lane. So the traffic lane starts
On the dotted lines.
where that dotted line is. That's
Oh,
the northbound
thank-
side.
Tim,
Stay-
that's exactly it. Thank
Yeah.
you.
Yeah,
Stay
that's
out of the
yeah.
purple.
Yeah,
Southbound.
you're exactly right.
Good question.
What's the wavy line that goes all the way across the chart? And it
That's an underwater cable. So it could be, you know, a small fiber optic cable. It could be a large cable. It's some sort of underwater cable.
okay.
When I worked on research vessels, we laid all sorts of underwater cables out there. It was like a whole array of spider web. And they're so deep, it doesn't really matter, but you're advised not to anchor there because you're going to mess up some real expensive equipment. We were doing measuring seismic activities to predict tsunamis or earthquakes.
Another question right at the same point, knowing the ferry route out to Catalina, is it advised to stay away from the ferry route?
Not necessarily advised. I wouldn't hang out on the ferry route going 5 knots because you're really going to annoy the ferry drivers. Because they're going to be zooming around you over. I mean, it's not, you know, against the law. You can't not go on the ferry route. It's the shortest distance from that port to that port. So of course you can. They're just saying there's some high-speed ferries going to be cruising along here numerous times throughout the day. So just to give you a heads up. And especially, you know, I mean, what are the ferries go now? Only like once a day with the whole COVID thing. But in places, you know, like Seattle, where they're going back and forth every 15 minutes, or even Balboa, you know, where the ferry is in Balboa, it's going back and forth pretty frequently. You don't really want to hang out in that area.
Captain, quick question on day 3 on question 23.
Go ahead.
It looks like you wrote, oh, never mind. I got it. Never mind. I see it. Thanks.
Yeah.
Captain, and just to confirm, you're going to do a video of each of the assignments?
Yes, it's posted right now.
Okay, great. I'm just slightly off, so that's why I want to go and watch that slowly.
Yeah, and slightly off isn't too bad. Your plotting skills will get better and better the more you practice. So even if you're just off by a little bit, it could just be, you know, a little jiggle here and there or a little wiggle of the dividers or something. So don't sweat the small little details. But yeah, check out the videos.
Great, thank you.
Any other questions before we go?
I don't.
No, thank you though. Thanks for the time to work on this with you present to help us.
Good, good. I'm glad. I wish I could see what you guys are doing, but one day we'll meet each other in person.
I'm lost at sea.
You're lost at sea.
Oh yeah, I'm just, it's dark. I don't know if my numbers are right, but I'm gonna check it out. I'm checking out the video.
Okay, check it out. All right, well, have a good weekend.
Thank you,
And
Captain.
next week, we're going to learn some more types of fixes. So get ready for that.
Cool.
Thank you.
Thank you very much.
All right.
Bye-bye.
Okay, thank you.